Alright, good morning, it's Saturday. This is your quiz review. So let me just get my markers ready and it should be. Alright, so let's see. Good. Question 1. Out of every 5 animals, 2 are dogs. Using pictures, find how many dogs there are when there are 20 animals. Okay, so out of every 5. So it means that if you have 5 animals, and let's represent that by using circles, 3, 4, 5. If I had 5 animals right here, and why is it doing that? Okay, 5 animals, okay, 5 circles. I'm going to label my first 2 with a D inside because it means that if I have 5 animals, 2 are dogs and the rest can be whatever. It doesn't really matter. Okay, so that's my ratio. But I want to know how many dogs I have under 20 animals. Okay, so I'm going to draw another set of 5. And here we go. Is that marker going up again? Okay. Another 5 circles. 1, 2, 3, 4, 5. And 2 of them are dogs. And I'm going to repeat this process. 1, 2, 3, 4, 5. And label my first 2 animals with D because they are dogs. So far I have 5 over here, plus 5, 10, plus 5, 15. I need another 5 because the problem says I have 20 animals. So 1, 2, 3, 4, 5, and first 2 are dogs. Okay, so if I have 20 animals, let's count the number of dogs. 1, 2, 3, 4, 5, 6, 7, 8. Answer: there are 8 dogs. Okay, this one I think is a matter of just reading the question carefully. Okay, and yeah, it's about it. It's not that difficult a question, but it's just reading it carefully, understanding that out of every 5, 2 are dogs. Okay, let's move on. In the class, there are 19 students. And from that, we know that 12 are boys. So from here, I can write 12 boys. All right? And it says create a part-to-part ratio and a part-to-total ratio. So let's start with a part-to-part. Part-to-part. Well, I know the problem didn't say it, but if I have 19 students and 12 are boys, it's a little obvious, okay, that the rest of the students are girls. So I can fill that piece of information in there. Okay, so I know it didn't say it, but we can assume that if 12 are boys, the rest must be girls. So I needed to have that information before doing my part-to-part ratio. So a part-to-part ratio would be 12 boys, and I'll abbreviate right B, colon, colon. You can use any other way you want, but I'll use colon, to 7 girls. Or, since they didn't specify, you could have written 7 girls to 12 boys. Either or would have been perfectly fine. Okay? And then it says create a part to total ratio. Part to total. Well, this one is a little bit simpler. So the total, here's my ratio. I'll use a fraction this time. I know there's a total of 19. And part of the 19 are boys. 12 or 19. Or, I'm sorry, we could have even done 7 to 19 because I know part of the 19 are girls. I'll even write a little B here and a little G here. So either or would have been completely acceptable. Okay? But the key to this question was knowing that it started with 19 students. If 12 of them are boys, you could safely assume that the remaining are 7 girls. And you needed that piece of information. Okay, especially to do the part to part. Question 3. Write 3 for every statement using the information below. The little ones at school are raising money for the children's ward at the hospital. Here are their goals. The second grade, $80. Third grade, $240. Fourth grade, $320. So let's say, let's compare the second to the third grade. I can write for every, okay, and for every $80, okay, that the second grade raises the third grade raises 240. It's a comparison. I'm comparing the second grade to the third grade. Likewise, I can do, I don't know, let's do fourth grade to third grade. For every 320, that fourth grade raised, okay, I should have said that in the first question too, raised past tense. The second grade raised $80. Okay, you're comparing the fourth to the second. Okay, and then you can do one more, and that you can work from, I guess we have it done, you can go from third to second, third to fourth, you can change the order, but you get the same thing. Okay, that was simple enough. Okay, next one. 4. Lisa spent 2/7 of her allowance. How much did she spend? How much does she have left? Okay, all right, some of you, I'm hoping you copied this because that was missing if it was blank. So for question 3, you needed, there should be a picture of a little box, 2, 3, 4, 5, 6, 7. A little bar like that, divided into 7 pieces, of which 2 are shaded. Okay, 2/7. And then there's a number line at the bottom that says that's 0, and this is $63. So Lisa spent 2/7 of her allowance. How much did she spend? So we want a numerical value here, okay, a dollar value to find out. And we know she spent as a fraction 2/7 of her allowance, but we don't know how much of how much that is in money. So there are 1, 2, 3, 4, 5, 6, 7 boxes. So we're going to obviously here 63 divided by 7 so that we can find out what each seventh is. So it's 9. Okay. So knowing that, we know that each 1/7 is $9. That's another $9. 9, 9. Actually, you know what? Instead of doing that, let me do it this way. Alright, so instead of doing that, I know this is 9, so if we count it by 9, the second one is 18, 27, 36. I love when it does that. 36, 45, 54, and then finally 63. So by dividing $63 by 7, which is the number of pieces here that we divided our bar, we can get the value for each bar. So each bar is worth 9, so you can start counting by 9. 9, 18, 27, 36, 45, 54. And that tells you exactly how much she spent. So she spent $18. And how much does she have left? Well, she has 63 minus 18. And that would give us 5 over here. And 45. So she has 45 left. $45 left. Okay. So the key here, or the only thing pretty much that you had to do, was finding out what each particular box was, and then you could have easily found the answers to the questions. 5. A large container holds 30 gallons. It is currently filled with 1/6 of water. How many gallons do you need to add it so that it's 5/6 filled with water? Make a drawing of the situation. Alright, so let's make a drawing. So here's a tank, a very crooked tank. Okay. Wow, I'm sorry. Let's see if I can do this better. I don't know why it's crooked. Here we go. Let's try this again. Sorry. Yeah. Okay. Here's a tank. Ooh. Okay. And let's cut it into 6. So we can cut it into 1, 2, 3, 4. Wow. Okay. Let's try this again because I obviously can't draw straight lines. Alright. So 1. Okay. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6. Alright. It's as good as it's going to get. So, I know, let's just shade this area, that this is 0. I know that the top is 30 according to the question. Here's a container. And so far, we have this much water inside. Okay, 1/6 is filled with water. So, we want to fill it up so that the water level goes all the way up to here. We don't want to fill it to the top, but just up to here. Okay, and that's, by the way, it's 1/6. So again, somewhat similar to the previous problem, okay, but the picture here, the drawing here, definitely will help you. So, this is the quantity that we need to fill in. Well, if I were you, I would find out what each 6 is in terms of gallon. So I would take 30 and I would divide that by 6 because there's 6 parts, and that gives me 5 gallons. Okay, 5 gallons. So I know that each section here, that's 5. This is also 5. This one is 5. This one is 5, 5, and 5. Okay, so I know that we have currently 5 gallons in here, and let me change colors to yellow. I want to add 5, another 5, another 5, and another 5. Remember, we don't want to fill this all the way to the top. We want to go up to 5, 6. So, from the current level that I have, which is right here, 5, and I want to fill it to 5, 6. Let's count the number of boxes here. I have 1, 2, 3, 4 boxes, and since I know each one is 5, so I need to get 5 gallons and do it 4 times, which means I have to add 20 more gallons. Alright? Okay, that's it for that question. Let me move on to the next. 6, another large container. Okay, so let's see if I can draw this even better. Here's a container, or a barrel. And it is currently filled with 3/12 of water. Okay, alright, who makes these questions? 1, 2, 3, hopefully you can draw these better. 4, 5, 6, 7, 8, 9, 10, 11, and I'll make that a little smaller. Okay, 12. Alright, so assume you have a barrel that is somewhat better than that. Well, this is 0. Okay, dividing 12 parts, and you know that top, if you fill it with water all the way to the top, is 48 gallons, big container here. And it's filled to 3/12, so let me fill this up. That's 1/12 2/12 of water and 3/12 of water. So at this level right here, it's 3/12 filled. Someone's going to add 20 gallons. Okay. How much water? What's the new water level going to be? Okay, so the drawing definitely comes in handy. What I would do here is the same thing. I would also find out what each 12 would be. Each little piece here. This one, this one, this one. All the way to the top. I know the total amount's 48. And it was divided by 12 pieces. Which gives me 4 gallons. So each line over here is worth 4 gallons. It's an increment of 4. So we got 4, 8, 12, 16. I'll actually write this down. 20, 24, 28, 32, 36, 40, 44. Okay? So increments of 4. 48 divided by 4 is 4, so we count by 4 all the way up. So now, excuse me, at the 3/12 level, we know that it's currently at 12 gallons. So it's sitting right here. Okay? So it is currently at 12 gallons. Somebody adds, so if it's currently at 12 gallons, and somebody adds another 20, it's going to go to 12 plus 22, 32 gallons. So I'm going to change colors over here to yellow, and this is 4, that's 8, that's 12, that's 16, and that's 20. If somebody adds this much water, which is represented by the yellow, 20 gallons, your new level, water level, water marker, will be right here, 32 gallons. Okay? Next question. The ratio of spoons to forks needed at a dinner party is 5:2 for every person that's going to attend. So, let me draw a person. So here's a person. Okay. And if he comes to dinner, he's going to get 5 spoons? Seriously, what was I thinking when I made this question? All right. Here's a spoon. Here's another spoon. Here's another spoon. Here's another spoon. Here's another spoon. All right. And then 2 forks. Okay. You can all make fun of my forks. Let me know Monday. All right. So if this person comes to dinner, he's going to get 5 spoons and 2 forks. 120 people are going to attend. How many spoons and forks are needed? Really? Okay, so let me just write that these are 5 spoons. These are 2 forks. Okay. Simple question, I think. Well, not that. Simple question. So one person gets 5 spoons and 2 forks. If I have 120 people, how many spoons and forks are needed? Well, basically this is what you have to do. 5 spoons times 120 is going to be 600 spoons. And 2 forks times 120 is going to be 240 forks. Okay? Simple question. Yeah, there's not much else to do. Next question. The ratio of, box E. Okay. Scissors. Okay, please don't. All right. Let's pretend this is a scissor. Okay? Oh, not bad. So a box contains 10 scissors of different sizes. That's another scissor. That's another scissor. I'm going to draw, actually we'll draw 10 of them for you guys. 4, 5, okay, 6, 7, 8, 9, and 10. Here are 10 irregulars, 10 scissors. Okay, so let's assume a box has 10 scissors of different size. Question is there a proportional relationship between the weight and the number of scissors? Well, think about that one slide I showed you guys where there was a scale and I had different boys on the side of different heights and different sizes, I guess. Right? And I asked, what happened when I put this first guy here? Great. All right. What happens when I put the first boy here? Assuming he weighs, I don't know, let's see, he looks like he's 30 pounds. We put this guy on the scale. The scale is going to say 30 pounds. We put this second guy on the scale. In order to be a proportional relationship, his weight should be the same. Every time we put a boy on that scale, the weight should go up by the same amount. Okay, so the ratio in this case would be, let's say, 1 boy 30 pounds, 2 boys 60 pounds, 3 boys 90 pounds. But you can tell by the picture that these guys are of different heights and obviously of different weights. So there's not going to be a proportional relationship here. So go back to your scissors right here. Okay. Take all your scissors out of the box and slowly start putting them one by one into the box. Okay, start with this one. And then put this one. Do you think the weight of that box is increasing in the same proportion? Okay, so obviously the answer to this question is no. There is no proportional relationship between the weight and the number of scissors. Okay. Next question. 9. The ratio of pens to pencils, 2 to 9. 2 to 9. These are pens. These are pencils. And if there are 12 pens, how many more pencils are there? Okay, so if there are, well, your ratio was 2 to 9, so for the 2, increase to 12 by a factor of 6. 9 is also going to increase by a factor of 6, okay, because the proportion, you proportion both have to multiply by the same factor, giving you 54. Okay, so if you have 12 pens, there are 54 pencils, but that does not answer the question. How many more pencils are there? Okay, if there are 12 pens, how many more pencils are there? Okay, you have 9 pencils in the beginning, and you started with 54. Okay, so 14 minus 9 is not 3, obviously. It's 5. 5. And then this one was, how many more pencils are there? Answer, 45. Okay, so this one, the way the question was worded, okay, you have to be careful. Yes, when there are 12 pens, you have 54 pencils, but that's not what the question is asking. The question is asking how many more pencils are there, okay? Once you start with 9. Okay, so if you start with 9, there are 45 more pencils than you initially had. Last question. Create a tape diagram to solve the following. Okay, here's a tape diagram. Bees to... Alright, let me write the ratio for bees to wasps. It's 4 to 5. Okay, so I want to create a tape diagram for the bees and one for the wasps. So this is 1. Okay, and I'll write bees here on the sides. And then wasps are the same. Okay, but they have 5 boxes. Oh my god. Okay, let's try this again. Okay. Wasps have 5 boxes. Alright, so we have a total of 60 insects. So we want to fill in 60 into all these boxes. Why did I use the number 60? That's not gonna work out. If you're doing this problem, okay, change. I know it's a little bit late, but change that number to 54. Okay. I'll give you a few seconds to think about what would happen if the number was 54 instead of 60. Okay, because 60 doesn't work evenly. All right, and we don't want to have. This is not the type of problem I want you to work with, so that involves decimals. So change that number to 54. That should work out nicely. So ratio of bees to wasps is 4 to 5. If I had 54 of those insects here, how many of them would be bees? How many of them would be wasps? Okay, using a tape diagram, I know that I have 54 and I want 9 squares, so 54 divided by 9 is 6, which means each of them would be 6 like this. So my final answer, once that's completed, is that if I had 54 insects, 1, 2, 3, 4, 24 would be bees. And 1, 2, 3, 4, wait, I'm missing a box here. Okay, 5 boxes. 1, 2, 3, 4, 5 boxes. 30 of them would be wasps, giving me a total of 54. Okay. So I forgot a box here at the end. So when I was initially setting the tape diagram, it should have been 4 boxes for bees because it's a ratio of 4, and then 5 boxes for the wasp because it's 5 over here, 4 to 5. Okay, each one representing a single insect in the beginning. Okay, that's about it. Should be pretty simple. Okay, so I'll see you guys on Monday. Thank you.